Hello students, welcome to Go Vidya. As we know that the 1000 question series, which are very important for TRANSCO and GENCO. In that series of 1000 important questions, we are going to solve some questions related to control systems. So let us see some control systems question series within this 1000 important questions, how we are going to solve and what sort of questions we can going to expect, and we will see one by one. Okay? Let us take this question. What this question? See, remember one thing, whenever if we are solving any question, please try to read the question and try to understand the question as much as possible. That means you need not to read 3 times or 4 times. At least try to read effectively at least once properly, if not at least twice, so that you will get the clarity on the question, what to solve, so that you can be easily able to answer the question. Okay? What is the question? Consider the following open loop transfer function. So what's the question they have given? They have given open loop transfer function. This is what open loop transfer function. So what they are asking? The characteristic equation of the unity, remember this, negative feedback. As you know that feedback system, negative feedback, that to unity negative feedback system. You have to be very careful this terminology. Why? Because sometimes the person who is going to create this question, he may ask like this, maybe positive feedback system. It can be possible. So unity negative feedback system. So unity negative feedback system means obviously it is a closed loop transfer function. First let us take the given transfer function g of s. What is that? G of s is equals to k into s plus 2 whole divided by s plus 1 into s plus 4. Actually this is the open loop transfer function, but we need the characteristic equation. What is the characteristic equation if it is a negative feedback system? We know that the characteristic equation is equals to 1 plus g of s into h of s is equals to 0, because it is a negative feedback system. If it is a positive feedback system, and this characteristic equation will become 1 minus GSHS equals to 0. Okay? So 1 plus GSHS equals to 0. So as per the given question, he mentioned that unity feedback. Unity feedback means this h of s value is going to be 1. So already we know g of s. So g of s into h of s means this entire transfer function multiplied by 1. So now what's the transfer function is going to be, or characteristic equation is going to be? Let us see. So can I write like this? 1 plus k into s plus 2 whole divided by s plus 1 into s plus 4, which is equals to 0. Okay, now you just rearrange this equation, then what you will get? Characteristic equation is equals to, so s plus 1 into s plus 4 plus k into s plus 2 equals to 0. This is what the characteristic equation of a given open loop transfer function. This is the characteristic equation of the given open loop transfer function. I hope it is clear. So therefore, what is the option? Which option is very close to our question? S plus 1 into s plus 4 plus k into s plus 2. Therefore, this is the option correct. Got it? So in the other way also we can solve this question straight away. He is asking the characteristic equation. Generally, characteristic equation is nothing but the denominator of closed loop transfer function. Closed loop transfer function. Whenever you have a unity negative feedback system, you have an open loop transfer function, don't do anything, straight away add both numerator and denominator. What is the note here? Shortcut. Whenever if it is a unity negative feedback system, straight away what we have to do? For characteristic equation, for this negative feedback system, what we have to do? Always add numerator and denominator equated to 0. That is what your characteristic equation, provided unity negative feedback system. Okay? Now let us see another question. If you look into this question, what is they're asking? Simply identify the transfer function of the system. Given this is the block diagram, so we have to identify the transfer function of it. So basically, whenever you are solving any question related to block diagram, to identify the transfer function, we need to use some block deduction techniques, etc., etc. But we know that we also can solve from the block diagram to signal flow graph, from signal flow graph to transfer function. So it is very easy, obvious that if we are using block diagram to signal flow graph and then to transfer function. So how to deal with this? So how many forward paths are there? If you see from this block diagram, how many forward paths? This is one forward path and this is another forward path. So total how many forward paths are there? There are total 2 forward paths. Number of forward paths are equals to 2. Do we have any loops in this particular block diagram? No, no loops are there in this particular block diagram. So therefore, number of loops equals to 0. So from the Mason's gain formula, we know how to write the transfer function from the given signal flow graph. So therefore, what is the transfer function? What is the transfer function? Transfer function is equals to number of forward paths. How many? 2 forward paths. So if there is no loops, obviously delta 1 and delta 2 value, right? What are those? Which is m1 delta 1 plus m2 delta 2. m1 delta 1 plus m2 delta 2 and denominator delta. And we know that what is the delta? 1 minus sum of individual loop gains plus sum of 2 non-touching loops, etc., etc. So here, can I say where m1 is nothing but the first forward path gain. So what is the first forward path gain? 5 by s plus 2. 5 by s plus 2. And what is the delta 1? Obviously there is no loop at all. So if there is no loop, then directly I can say the delta 1 value. And as well as you see, for second forward path also, do you have any loop? No. So therefore straight away I can say this delta 1 and delta 2 values are straight away equal to 1. Now what else left? m1 plus m2. What is m2? 4 by s plus 1. But here the important thing which you need to observe is this is the negative sign. This is the negative sign. So therefore you have to put minus in between, and what else left? That is 4 by s plus 1. And provided do we have any loops? No loops. So therefore obviously delta value is equals to what? How much? It is 1 only. So therefore 1 I can put in the denominator. Then you resolve it. 5 into s plus 1 minus 4 into s plus 2 divided by s plus 1 into s plus 2. You simplify this. 5s minus 4s, which is nothing but the s. 5 minus 8. 5 minus 8, which is nothing but minus 3. And the denominator is s plus 1 into s plus 2. S plus 1 into s plus 2. This is what exactly our transfer function. Suppose if you are, by overlook, if you have not seen this negative sign, so what will happen? You will also think that it is positive. So both you will add. If you add both, what you will get? 5s plus 4s. Suppose if you take wrong assumption, 5s plus 4s, which is nothing but 9s. 5 plus 8, 13. It is there in the option. So there is a lot of chance to put this is as the correct answer. But actually this is wrong answer. So what is our actual correct answer? The actual correct answer is this one. Understand? Remember, whenever if you are doing any conversion from block diagram to signal flow graph, it is a very important the sign. If you are by overlook, you assume that basically forward paths are always positive. No, it's not right. It's not like that. Depending upon the sign, it is like a trap. Okay, usually you might fall under this trap. So definitely you will get this option as a correct answer, but to be frank, it is not correct. This is the correct answer. Okay. Now, let us see another question. You read the question. What is that? The type of the control system represented by the block diagram shown below. So, this is what called GS. Can I say that? This is what called G of S. What about this? What about this? This is H of S. Okay, this is H of S. So what is there asking? What is the type of the system? What is that? Type of the system. Type. What is the type of the system? So generally type of the system is meant for open loop. But actually it is looks like a closed loop. But what is its open loop transfer function? The open loop transfer function of this is, how can we write? Open loop transfer function, which we are going to write like this. What is that? Simply GSHS. GSHS is your open loop transfer function, right? Provided it is a negative feedback. See, negative feedback, right? GSHS. So what you need to do, simply just multiply these two. What is that? Simply multiply these two. So because I am interested towards to the type of the system. Basically what is meant by a type of the system? What is meant by a type? Generally type is going to define the number of open loop poles at origin, right? Number of open loop, the number of open loop poles at origin. How many number of open loop poles at origin we have right now? Generally what we think, majority people, that number of poles at origin is 3 because it is S cube. But the here important thing which we forgot is the feedback element is not a constant value. It is also having some poles, 2 poles at origin. So if you look into this, I told you GSHS, because our objective is number of open loop poles lying at origin. So we are not at all bothered about the numerator what we have. So always I will focus on denominator what we have. If you check from the block diagram, the denominator which will give you what? Observe very carefully. S cube into S plus 1 into S plus 4. This is GS from the denominator I am talking about. Forget about the numerator because we are not interested in it. And what about the denominator for this feedback element? What we have? S square. Correct na? So now what you need to do, just multiply this. So therefore these are 3 poles at origin and these are 2 poles at origin. Therefore totally how many poles at origin we have? Total 5 poles at origin we have. 5 poles at origin we have. 5 poles at origin means what? The type of the system is, this indicates what? Type of the system. This indicates type of system. Therefore, what is our answer? Type 5. But generally what we expect, this is what we are going to expect, right? So therefore immediately people will choose this is the correct answer, but obviously it is not. What is that? Type is 5. I hope you understand. So therefore first, before understanding how to solve this problem, first you have to know what is the definition of type of the system. What is the type of the system? Number of open loop poles at origin. So from that our interest is only poles. So that's why I have directly taken like this. Okay. Now let us see another question. it is a kind of match the following. So generally these type of questions you may expect in the TRANSCO and GENCO. The reason why they will give this is here we are going to waste our time because they want to kill our time. Okay, so that's why you may get some kind of match the following type questions. So how to solve, even though if it is a match the following questions. So if you see list 1, transfer function of the system, means this left side all are transfer function of the system. List 2, type and order of the system, type and order of the system, and select the correct answer using the codes given below the list. So but observe one thing, did they mention about anything related to open loop or closed loop? No. Straight away you see here type of the system we are going to identify by taking the option A, option B, option C, option D, right? So obviously they have not mentioned anything, so straight away we can consider these are the open loop transfer functions. So from this you see from the option A, you see here what is the type of this option A, which is nothing but number of, as I mentioned, what is the type of the system? Number of open loop poles at origin. So how many poles are there at origin here? S raised to the power of n. So therefore for the option A, what is the type of the system? The type of the system is 1. And what is the order of the system? What is the definition of the order? Generally order definition is nothing but the highest degree of the polynomial, the highest degree of the polynomial of a transfer function, denominator value. So what is that? Highest degree in the denominator of polynomial, highest degree. So you tell me what is the degree of the system? It is 2, right? S square plus 5s. So therefore order is equals to how much? It is 2. So option A, type 1 order 2. So type 1 second order. So you see option A is 2. So therefore I can eliminate these two options. Only thing is A or C, anyone should be correct. Now suppose, see, instead of solving everything, I already eliminated the two options. So what else left in this common? So A is 2 2, C is 4 4. So if I check either B or D, that is the problem, right? So let me check the B. So what is the B here? So from option B, what I'm going to calculate, can you tell me what is the type of the system? Is there any poles at origin? So can I write like this is like S power 0? So therefore number of poles at origin is how many? 0. So therefore type is equals to 0. And what about the order? The order of the system is S into S, S square. So order is 2. So therefore type 0, order 2. So therefore B is 1. So therefore option A is correct. You see here A 2, C is also 2, C 4, it is also 4. Now C, only thing is left is what? Either B or D. We checked any one. So B I checked. It is showing that type 0 order 2. Type 0 order 2. What is the type 0 order 2? Option 1. So option 1 means this is the correct one. For our sake, let us see what exactly the D also. So tell me, is there any type of the system? No. See, type 0. So type 0, obviously which is left? Only the third one. So type 0 order is S into S into S. So therefore from option D, what is that? From option D, can I say that, yeah, type of the system is 0. Type of the system is 0 and the order is 3. Type of the system is 0 and the order is 3. So therefore which is the correct answer? This is the correct answer. Remaining 3 are the wrong answers. I hope clear with this question. Now let us see one more question. Now if you see in this question, they have given the closed loop transfer function of a unity feedback. So did they mention about anything related to negative or positive? No. So if they're not mentioned whether it is a negative feedback or positive feedback, so what we need to consider all the time? All the time it is a negative feedback. All the time we have to consider the negative feedback only. Why? Because our majority of the systems are nothing but only negative feedback systems. Now what they're asking the question, that is open loop transfer function. Open loop transfer function of the system. So open loop transfer function means how to convert closed loop to open loop. I'll tell you the trick. So whenever if you are having closed loop transfer function, you have a CLTF. You have CLTF. But I want to represent that is in terms of negative, like open loop transfer function. So open loop transfer function, how to represent? It is simple. The numerator of the closed loop, keep it as it is. Numerator of CLTF divided by numerator of closed loop transfer function divided by denominator of CLTF minus numerator of CLTF. Got it? Numerator of CLTF divided by denominator of CLTF and numerator of CLTF. That means simply I can write the open loop transfer function numerator as it is, we are going to give, and denominator is what? S square plus 10s plus 25 minus, yes, numerator. What is the numerator? 25. So can I write like this, which is nothing but 25 divided by s square plus 10s. From this, can I take the common? 25 by s into s plus 10. 25 by s into s plus 10. So which is the correct answer? So this is the correct answer. Which is the correct answer. Similarly, if you want to convert from open loop transfer function to closed loop transfer function, simply what we need to do, put a note here. Put a note. I want to convert from OLTF to CLTF. What about here? CLTF to OLTF. Now we are doing reverse. How to do that? Simple. CLTF is equals to, if you have open loop transfer function, let us take this one. So how to deal with this? Simply numerator of OLTF divided by numerator of OLTF plus denominator of OLTF. By using this logic, you tell me what is the closed loop transfer function of it. Just add numerator to the denominator, that's it. So s square plus 10s, if you do add 25, so you will be getting the same transfer function. So therefore, when we are moving from closed to open, that means we are decreasing. So you need to put negative sign. When we are moving from open loop to closed loop, that means we are increasing. So put plus, whatever the transfer function they have given. Okay. So therefore our option is 25 by s square plus 25. I hope it's clear with this question. Now let us see another question. So now let us see, it is a block diagram. They have given the transfer function of the block diagram. From this diagram they are asking what is the transfer function of it. How to deal such questions? Looks like somewhat complex when you see from the block diagram point of view, but as I mentioned, from the block diagram we can convert to that signal flow graph. Once if you know how to convert from the block diagram to signal flow graph, then it would be very easy for us to write into the transfer function. So for that, what we need to do, identify the number of forward paths. Number of forward paths. How many forward paths are there in this block diagram? So if you see, this is the one forward path, and this is another forward path, right? So therefore 2 forward paths are there. So number of forward paths are 2. Is there any loops in this? How many loops are there? There are 2 loops are there. How? This is the one loop. This is the one loop. Another loop is what? This is the another loop. This is the loop 1 and this is the loop 2. So how many loops are there? There are total 2 loops are there. So loops are equals to 2. Tell me, these 2 loops are touching loops or non-touching loops? Obviously these are touching loops. So then there is no like concept of non-touching loops in this particular block diagram. So how to solve this question? We know that from the signal flow graph, the transfer function is going to define like number of forward paths, how many? M1, because 2 forward paths, M1 delta 1 plus M2 delta 2 whole divided by delta. But as I mentioned, delta 1, delta 2 calculation is more important when we go for the signal flow graph. So what is a delta 1 for this particular thing? You have the loops, right? So I have to calculate the delta value which is not having the same forward path gain. So that means M1 may, how many loops are there? 2 loops are there, but that forward path including these 2 loops are not. Yes. So in that case, this delta 1, similarly, when you see the second forward path, where is the second forward path? This is the second forward path, right? This is the second forward path. In this second forward path also, this path is touching each loop or not? Yes, this forward path, is it touching these 2 loops? Yes, it is touching these 2 loops. So therefore again, the delta value is going to be 1 only. So therefore finally, delta 1 value and delta 2 value both are equals to 1. So straight away I can write what is M1 here. Forward path gain of the first forward path gain is what? G1, G2. G1, G2 plus what is the second forward path gain? G1, G3. Both are positive only. Care must be taken when you have signs here. So Z1 and Z3 whole divided by, yes, now we have to write the delta 1 minus. So is there any non-touching loops? No. So we have to focus mostly on individual loop gains. What is the first loop gain? You see here, this is the loop 1. If you see, so G1, G2, it is going like this and coming like this. So G1, G3, G1, G3 and H. With what? Negative sign, minus G1, G3, H. Right? Another one is what? G1, G2 and H. Both are negative feedback. Minus G1, G2 and H. Now simplify this. G1, G2 plus, this is Z1, yeah, Z1, Z3 whole divided by 1. Both are minus, you take it minus outside. So 1 plus G1, G3, H plus G1, G2, H. So which option is very close to our question? G1, G2 plus G1, G3. So G1, G2 plus G1, G2 plus, yes, G1, G3 by 1 plus G1, G2H plus G1, G2H. So therefore what is this answer? B is the correct answer. You see, don't confuse. See, G1, G2 plus G2, G3. So obviously this is not correct. Check the numerator. G1 negative is there, not correct. So G1, G2, this. So there is a possibility between these two. So in this very clearly it indicating you have G1, G2H, here G1H. So straight away we can mark this as the correct answer and this is the wrong answer. Clear now? So therefore try to understand the conversion of block diagram to signal flow graph, then it will be very easy for us to solve the numericals. Okay. So this is about this transfer function from the block diagram using SFZ. Very, very important. Conversion of block diagram to SFZ. much more important. Okay, so now let us go to the another question. So if you see, for the system in the figure, the transfer function C of S by R of S. So for this C of S by R of S, they have given like how? P by S square plus RS plus Q. They have given like this, P by S square plus RS plus Q. This is what they have given transfer function like this. Now what is they asking? P plus R plus Q value is how much? So first let me write the transfer function for it. So the transfer function, let me do it here. The transfer function is like this. Again, same story. Try to identify how many forward paths are there. I can say one forward path is there, rest of the two are loops. Correct only, na? So number of forward paths are 1. Number of loops, how many? It is 2. You see here, this is one small loop and this is one big loop. Correct, na? So for the first forward path, what is the gain? Both are positive only. So therefore, what is the gain? 10 by S into S plus 1 whole divided by. Now how many loops are there? 2 loops. Both are negative feedback. Both are touching or non-touching? Both are touching only. So then there is no concept of 2 non-touching, 3 non-touching loops in it. Okay, right? What is the transfer function? 1 minus. What is the first loop gain? Can I say minus 10 by S into S plus 1, this one, multiplied by GSHS na, into S. Okay. Next one. Let me erase this. Yeah. Next one plus. What is another loop gain? Simply, this is 1. Nothing is there means unity feedback. So can I write like this? Simply again minus 10 by S into S plus 1. I hope it is clear. Correct, na? So now if you take LCM, this is minus, take minus outside. Minus into minus plus. So numerator, it is 10 whole divided by. What else left in the denominator? So can I say S square plus, this is S, na? S square plus S, yes, plus 10S plus 10. Correct, na? S square plus S, you take LCM, minus taken outside, this is plus. So S square plus S plus 10S plus 10. So therefore from this, can I say which is equals to 10 by S square plus 10S plus S, 11S plus 10. Correct, na? So now just what we have to do, just compare the values of P, Q, RS and then we can calculate this value. What is the P value when you compare? P equals to 10, R equals to 11 and Q equals to 10. Don't cancel this S and S immediately because after that again you will feel somewhat difficulty while doing this LCM and all. Keep it as it is. So therefore what is the P plus R plus Q is equals to 10 plus 11 plus 10, which is nothing but 31. So this is your answer. So the answer is 31. Okay, very simple. What they have asked is indirect question. Till now what they are asking is given the block diagram, asking the transfer function straight away. So now reverse. They have given the block diagram, they have given the transfer function, but they are asking the unknown values with respect to this. What are those? P, R, Q. Okay? So this is a very, very important model. Very, very important model. Try to practice these models very well. Try to practice these models very, very well. Okay? Now, I hope you are clear with this question. Now, let us see one more question. Okay, it is also a particular question related to transfer function. But here the transfer function, it is a value here. This is what? Value. So now we are going to calculate the transfer function value. As usual, signal flow graph I will use. When I have the transfer function, I'll always use block diagram to signal flow graph, and then I have to convert into this. So how many forward paths are there? You just check from here. The number of forward paths are equals to how many? This is one forward path. See, this is one forward path. Where is another forward path? This is another forward path. Where is another forward path? This is another forward path. Is there any loops? No loops. Okay, loops are equals to 0. Therefore, total 3 loops. All are positive. Sorry, loops are 0, forward paths are 3. All forward paths are positive, 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 positive. So no need to bother about the sign. So straight away, what is the from Mason's gain formula? From Mason's gain formula, what is the transfer function? C of S by R of S is equal to, yes, how many forward paths are there? 2 into 3. So its value is 6, first forward path. There is no loop, so no need to bother about the delta 1 and delta 2. Plus, why I am taking straight away plus? Because all the signs are positive only. Another loop is what? This red color, second red color. See, this is the one. So 3 is another forward path. Again plus. Where is another forward path? You see here, this is the blue color one. This is another forward path. But the value is nothing here. So what's the value you are going to choose? The value you are going to choose is 1. So therefore its value is 1. Do we have any loops? No. When we don't have any loops, what is the delta value? Straight away we can put 1. So therefore, what is the straight value here? 6 plus 3 plus 1, that is 10. Most important model this is. Okay. I hope this question is clear. Only thing is you need to find the transfer function of it. Identify the forward paths and loops. There only you have to care must taken, provided sign is also important. Okay. Now let us see one more question. So this is one of the common question which generally we can expect. The transfer function of a linear system is. So here he used a word called linear system. So don't confuse about it. Most of our transfer functions or systems are LTI systems only. Most of our systems are LTI systems only. Okay. So what is generally the transfer function of a system? Is defined as a ratio of output by input, or the ratio of derivatives of output by input, the ratio of Laplace transforms of the output and that of the input with initial conditions are 0, and none of this. So when we are talking about the LTI system and especially talking about the transfer function, so generally transfer function is defined for under transfer function is defined for Laplace transform of output divided by Laplace transforms of input, provided, this is a very important, provided initial conditions are 0. Initial conditions are 0 because examiner clearly mentioned the linear system. Whenever if you have any initial condition, then it will not obey the linearity of the system. Okay. So care must be taken what is the terminology they have used. So mostly what they will say, either linear system or a system or a control system, anything, the answer is always, remember, initial conditions 0. Another option maybe they may give same to same, copy paste, the fourth option is, but instead of initial conditions are 0, they may give like initial conditions are finite. Initial conditions are finite. So obviously from out of these 4 options, this option is very close to our actual question. Okay. So therefore this definition we should not forget. Initial conditions must and should. Initial conditions must and should. Okay. I hope this question is clear. Now let us see the next question. So now look at this question. a signal flow graph is shown in the following figure. Consider the following statements regarding the signal flow graph. So what is that? There are two forward paths. These are the forward paths. These are the two forward paths. There are three individual loops. There are two pair of non-touching loops. There are two pair of non-touching loops. Let us see which is the correct one. First of all, identify there are the three forward paths. So in every four options, in every option you see one is common. Let us see whether it is having three forward paths or not. You see, this is one forward path. What is the first forward path? B1, B3, and it is B8, and B9, and B10 are the forward paths. Another forward path is B1, B4, B9, B1, B4, B9, and B10. Correct? Another forward path is B1, B6, B10. B1, B6, B10. So three forward paths. So obviously you can eliminate option C. Okay. Now, how many individual loops are there? So this is one loop, and this is another loop, and this is another loop. है ना? So therefore, how many individual loops are there? There are three individual loops. So therefore, 1, 2. So this also we can eliminate, because here there is no option 2. Two pair of non-touching loops. Yes or not? You see, this and this, is it touching? No. This and this, is it touching? No. So this is a one pair which is not touching. This is another pair, this is not touching. Therefore, two pairs of non-touching loops. Can we say that? Yes. But these two are touching. Understand? With respect to this loop, both are not touching. With respect to these loops and with respect to this loop, both are not touching. But when we see together, like these two loops are touching, right? So therefore, two pairs of non-touching loops are also exist. Therefore, this is the correct answer. So therefore, out of all the three options, this is the correct one. Okay? Care must be taken. Non-touching loops, you have to be careful.